And we've discovered that the quiet sun magnetic field is replaced in about 40 hours, less than 2 days. And that brings more than enough magnetic energy to the surface to heat the corona. As you say, that people have now come to the conclusion that magnetic fields are the most probable and probably the only source of energy to heat the corona.
We now understand that various activities of the sun, including coronas, are controlled by the energy of the magnetic fields covering the sun.
When the plasma particles, which form the beautiful coronas, are released from the energy of the magnetic fields, they spread out into the outer space of the solar system at a furious speed. These plasma particles cause strange phenomena in a variety of places. Let us now take a look at a few of these.
This is an image taken by the SOHO corona graph. The plasma particles which form the corona are released into outer space with a tremendous force of more than 1 million tons a second. The plasma particles released from the sun's lines of magnetic force spread like a wind in every direction at the furious speed of more than 1 million kilometers per hour. This is a plasma flow called a solar wind. The solar wind crosses and spreads way beyond the orbit of Pluto, the outermost planet. The range that the solar wind reaches is thought to be somewhere around 100 to 150 times the distance between Earth and the Sun. Some even believe that the range of the solar wind is the boundaries to the solar system. The solar wind reveals many astronomical phenomena to us. These are comets trailing long tails in the night sky. The tail of this beautiful comet was created by the solar wind. When comets get close to the sun, the ice on their surface is melted by the sun's heat and light, and then gas and dust begin to blow away. Comets have two kinds of tails. Thick yellowish tails glitter when their fine dust particles reflect the rays of the sun. On the other hand, pale-colored tails are produced when ionized gas, charged with electricity, is blown off by the solar wind. The aurora visible at the Earth's north and south poles are also the work of the solar wind. The solar wind is a flow of electricity-charged plasma particles. Because Earth contains a magnetic field, it is generally protected from solar winds blowing directly on it. However, when the flow of a solar wind gets stronger, large quantities of plasma can pour down on the Earth from the polar regions. The aurora are created when plasma collides with the Earth's atmosphere. Aurora are seen most frequently during times of vigorous sun activity. We now understand that about every 11 years, the sun repeats periods of violent activity, called maximum periods, and quiet minimum periods. Yoko, Japan's solar observation satellite, was the first in the world to successfully observe, continuously, changes in the sun's activities, from maximum to minimum periods with X-rays. During the maximum periods, several sunspots appear and the solar wind becomes stronger. However, during a minimum period, sunspots decrease and the solar wind becomes relatively gentle. These differences in the sun's activity are reflected in the shape of coronas. Coronas in a maximum period are large and wrap around the sun in a circle. Coronas in a minimum period, on the other hand, are less vigorous and appear to be stretching outward from the equatorial region.
Why does the sun's activity repeat maximum and minimum periods every 11 years? Humanity does not yet know the answer. Indeed, as to whether the sun will continue to tick along forever at the same rhythm, human beings have found no clues laying about. Will the sun continue to shine without any change? There is a female astronomer who is trying to find the answer to that question.
This is a suburb of Los Angeles in the United States. This is the Mount Wilson Observatory.
Letter O, the star number.
In order to predict what changes will occur in the sun's activities in the near future, Dr. Sally Baliunas of the Harvard-Smithsonian Astrophysics Center has, for the past 30 years, been selecting and observing the state of activity 30 individual stars of approximately the same size and age as the sun. One of these, located in Pisces, is a star called HD 3651. Like the sun, this star cyclically repeats periods of intense activity and periods of weakened activity. The cycle is 14.6 years. However, the activity of HD 3651 began to weaken in 1985. And for 12 years until the present, its activity has remained weak.
HD 3651 stopped having its sunspot cycle and fell into this state of low magnetism very quickly. Now imagine if there's a planet orbiting that star, and imagine if there are people or the equivalent of intelligent people there. They'd be experiencing a little bit less energy coming from their star. The star would be dimming by about 0.5% in total brightness. And because it dims and cools a little bit, its climate in response cools off. What was surprising was that it happened without any announcement or warning, as the star just stopped varying. So it tells us that there will be very little indication of what the future of the the loss of the magnetic cycle will be, and very difficult then to predict or to know many decades ahead of time. Now, when we look back at the history of climate change on the Earth and look at the times when the sun was in the low magnetic states, there's some very interesting effects. The global temperature of the Earth dropped about 1 degree centigrade. At the most pronounced last episode was in the 17th century.
Dr. Baliunas searches for the future shape of the sun in other stars. Today, too, she continues to gaze through the telescope. In April of 1998, TRACE, a new solar observation satellite, was launched. It is now rapidly sending back vivid images. This is an image taken with ultraviolet rays of the sun's active region. The form of the beautiful lines of magnetic force are definitely captured more minutely than with the SOHO ultraviolet telescope. From the data sent by TRACE, another new face of the sun will undoubtedly be explained. Although it is the star most familiar to us, the sun is still brimming with many riddles. The challenge to discover its true face continues at this very moment.